Okay, Assalamualaikum and good morning. Boleh dengar dan nampak skrin dekat sini. Okay, so today we will continue with the last subchapter for chapter 2. Your test 2, your midterm test will cover chapter 2, part 1 until part 7. Okay, and also chapter 3, which we will cover on Thursday. Okay, so the final part for chapter 2 is the mesh analysis. Okay, so what is mesh analysis? If you look at in your slide over here, mesh analysis is another procedure for analyzing circuit using mesh current as the circuit variable. So last week you have learned how to analyze circuit using the nodal analysis. So basically nodal analysis, we use the KCL, Kirchhoff current law. However, for the mesh analysis, we'll use the KVL, which is the Kirchhoff voltage law. So I hope that you still remember what is KCL and also KVL. So the nodal analysis, this one is what I explained to you just now. Nodal analysis applies KCL to find unknown voltages, while mesh analysis applies KVL to find unknown currents. Okay, so if you remember last week, for the nodal analysis, the questions mostly ask you to calculate for the current. Okay, however, for the mesh analysis today, for nodal analysis, you are asked to measure the voltage. Okay, nodal voltage. However, for the mesh analysis today, uh, you are required to calculate for the current. Okay, mesh current. So a mesh is a loop which does not contain any other loops within it. Yeah. So how to actually analyze the circuit using mesh analysis? So there are several steps. Over here we have 4 steps. So if you remember, for the nodal analysis, we have 5 steps. Okay, for mesh we have 4 steps. Okay, and you need to follow these steps one by one. Okay, so the first step is basically identify the mesh. Okay, you must identify how many mesh or loops are in the circuit. Okay, so after you identify the mesh, you need to assign the mesh current. Okay, so if you have 3 mesh, then you will have 3 current, I1, I2, and I3. If you have 4 mesh, meaning you need to have 4 current, I1, I2, I3, and also I4. Okay. And the third one, apply Kirchhoff voltage law to each of the meshes and use Ohm's law to express the voltages in terms of the mesh current, and lastly solve the resulting simultaneous equation. Okay, like I explained to you last week, for the simultaneous equation, you can directly just use your calculator. Okay, so to calculate for the current. So now let's directly look at the example. Okay, so for example, you have this circuit. Okay, you have this is voltage source. You have 2 voltage source and 3 resistor. Okay, so the first step, you need to identify the meshes or the loops. Okay, so from this circuit, you can see that we have 2 mesh. So this is the first mesh, the first loop. This is the second loop or the second mesh. Okay, so you have 2 mesh. So this next part is you need to assign the mesh currents, okay, I1, I2, to the meshes. So since you have 2 mesh, so we only have 2 currents. So the first mesh over here, we have current I1. We name it as current I1. And the second mesh, we name it as the current I2, or okay, I1 and also I2. The next step is apply KVL to each of the n meshes and uses the Ohm's law to express the voltages in terms of the mesh current. Okay, so remember Ohm's law. The Ohm's law is V equals to. Okay, so if you still remember your Ohm's law, so Ohm's law is V equals to IR. Okay, so for example, if we want to measure the voltage at this resistor VR, so the voltage VR is actually equals to I1. See, this is current I1 multiplied with R. Okay, but if you have a circuit where the resistor is connected in uh, in two loops, okay, so over here, this is, for example, this is loop 1, this is the second loop, okay. So in order to calculate for the voltage over here, VR is equals to I1 minus I2 multiplied with R. Okay, so this one I will show you later in the example. How do you get this? Okay, so if you look at this circuit, so you need to find the KVL equation for each mesh. So let's look at the first mesh over here. So this is the first mesh or loop 1. Okay. So the loop 1 over here, the KVL equation is actually negative V1. Okay, we have V1 over here. Since this is positive negative, so it is negative V1 plus 1, this is 1000, 1000 multiplied with I1. Why I1? Because the current that flows over here is current I1. Okay, plus 1000, this is another 1000 ohm over here, 1 kilo ohm. Okay, multiply with I1 minus I2. Okay, so this is where this actually comes in. Okay, where you have a resistor in between two meshes. Okay, so if you have a resistor like this one, it is located in between two meshes. Okay, so the voltage across the resistor 1 kilo ohm over here is actually 1K, 1 kilo multiplied with I1 minus I2. Okay, equals to 0. Okay, and then if you simplify this equation, you will get 2000 I1 minus 1000 I2 is equals to V1. So this is our first equation based on loop 1. Okay. Now let's look at the loop 2, second loop. So the second loop, we have the first resistor over here. Okay, this is the current I2. So the voltage here is actually 1000 I2 minus I1. Okay, because now we're looking at the second loop. So this will become I2 minus I1 plus 1 kilo ohm multiply with I2 plus V2. Why plus V2? Because it is positive negative. Okay, so the direction is the same as I2. So it is positive V2. Okay, this one is opposite direction. That is why we have negative. So if you simplify this this equation, you will get negative 1000 I1 plus 2000 I2 equals to negative V2. And this is the second equation based on the loop number 2. Okay. So now the last part is you need to solve the resulting simultaneous equation to get the mesh current. Okay, so now you want to actually determine the value of I1 and I2. Okay, mesh current is this one, I1 and I2. Okay, so let V1 is equals to 7 volt. So in the previous slide, we don't know the value for the voltage source, right? So now let's assume V1 is equals to 7 volt and V2 4 volt. Okay. So when you assume V1 is 7 volt and V2 is 4 volt, then only based on the two equations that you obtained just now, you can use your calculator to solve for the simultaneous equation, and you can directly get the V1 equals to 7 volt, I1 equals to 3.33 milliamp and I2 is equals to negative 0.33 milliamp. Okay, I hope that you can understand. Okay, so basically from this equation, okay, so you have 2000.
Doctor,
Yeah.
for the loop, for the V2 and V1, they say in the here that will be 7 minus 4. Actually, I am to ask about the there is a voltage divider rule. We saw it. So if the voltage is opposite of the loop, then there will be V2 minus V1 or V2 plus V1.
Sorry, can you repeat your question?
Um, in here, the current is going to the according to the loop I1 and I2. So in the voltage divider rule, maybe we calculate if there is two voltages in the two loop. So if the voltage is the same direction as the loop, so that would be V1 plus V2 or V1 minus V2.
V1 minus V2. Are you talking about this example or are you talking about voltage divider?
Okay, doctor, I'll share this question later.
Okay. Okay. So, so we continue this one. Back to our slide just now. So from this equation, remember you get the first equation is 2000 I1 minus 1000 I2 equals to V1. Okay, so this is the first equation based on loop 1. And the second one, we have negative 1000 I1 plus 2000 I2 equals to negative V2. So this is the second equation. So now I said that we assume V1 as 7 volt, V2 as 4 volt. Okay, so now we can change this to be 7. This will be, and you just use your calculator. Okay, key in these values, you will directly get this. Okay, I1 equals to 3.33 milliamp and I2 equals to negative 0.33 milliamp. So you can try to use your calculator. You should get this using these two equations. Okay, so this one, if you want to calculate for the mesh current I1 and I2. But if you want to calculate I naught. For example, I naught is over here. This is I naught. I naught is in between I1 and also I2. Okay, so how to calculate I naught? So if you use KCL over here, for example, this is node A. Okay, this is the current direction. So basically, you know that I1 is equals to I naught plus I2. Okay, so I1 is equals to I naught plus I2. Then you can calculate for I naught. So I naught is equals to I1 minus I2. Okay, so I1 is 3.33 milliamp minus negative 0.33 milliamp. Then you will get the value for the I naught. Okay. So now let's look at this example. Okay, so this PDF for the examples, I've already put it in the ULearn. Okay, so you can download this from the ULearn. Okay, so now let's look at example 1. You are given this circuit. The question asks you to calculate I1, I2, and also I3. Okay, so I1 is this one. This is I1. This is I2. And this is I3. Okay, so the first step is, okay, remember the 4 steps. So the first step is identify the mesh loop. Okay, so you have 2 loops over here. This is loop 1. This is the loop 2. Okay, so the next steps, assign mesh currents I1, I2. Okay, so the loop 1 over here, I assign this current as I1 and this current as I2. Okay, so now we're already at the second step. Now the third step is apply KVL to each of the mesh. Okay, so the mesh 1 over here, look at here, this is positive, negative. So this is counterclockwise. It is opposite direction compared to I1. So this is negative. Okay, so you have negative 15 plus the voltage over here. So the voltage at 5 ohm here is 5 multiplied with I1. Okay, 5 multiplied with I1 plus you have a resistor over here. So 10. So now we look at loop 1. So 10 multiply with I1 minus I2. Okay, I1 minus I2 plus, okay, you have another voltage source over here and the direction is the same as current I1. So you have plus 10 equals to 0. Okay, so if you simplify this one, you will get 15 I1 minus 10 I2 equals to 5. Okay, so this is the first equation, first KVL equation based on loop 1. So from the loop 2 over here, okay, so we have, so the first resistor is this one. So we have 6 multiplied with I2 plus, this one is still I2. So plus 4 I2 plus 10 I2 minus I1. And this one is negative 10. Okay, so if you look at the direction of current is the opposite direction. This is positive, negative. So the current over here is downwards. This one is clockwise. Okay, so that's why negative 10. Okay, so over here I don't actually during the lecture on KCL and KVL, I usually draw the current direction on at each element. But over here, I didn't show the direction. Okay, but if you get confused, my advice is that you draw the direction of the current. Okay, for each element. Okay. So if you simplify this equation, you will get negative 10I1 plus 20I2 equals to 10. Okay, so you have two equation. So you have two unknowns, I1 and also I2. So if you use your calculator directly, you will get I1 equals to 1 ampere and I2 equals to 1 ampere. Okay. However, the question also asks you to calculate for I3. Okay, so I3 is over here. Okay, so from the KCL, okay, over here, you know that I1 is equals to I2 plus I3. Okay, I1 equals to I2 plus I3. So I3 is I1 minus I2. So when I1 minus I2 meaning 1 minus 1, so you will get 0 ampere for current I3. Okay. I hope you can understand this. You just follow the 4 steps. Okay, and this mesh analysis is basically simpler than the nodal analysis that you have learned last week. Okay. Now let's look at example 2. You have this circuit. The question asks you to find I1 and also I2. Okay, so I1 and I2 is the mesh current. So this is I1 and this is I2. Okay, so over here I already identified the mesh loop and I already assigned the mesh current. So I assign this as I1 and this is I2. Now directly we go to the third step, apply KVL to each mesh. Okay, so from over here we have, okay, this is positive, negative. I1 direction is like this. So this become negative 12. Okay. Negative 12 plus 2 multiply with I1. Okay. And over here, we have a resistor that is located in between two loops. So this the voltage across this resistor will become 12 multiply with I1 minus I2. Okay, plus this one 4 multiply with I1. So that's why you get this equation equals to 0. So if you simplify this equation, you will get 18 I1 minus 12 I2 equals to 12. Okay, so this is the first equation. Now let's look at the second equation. Find the KVL equation for the second loop. So over here we have 12 ohm. So the voltage here is 12 multiplied with I2 minus I1 plus we have 9 ohm. 9 multiplied with I2 and then we have a voltage source. Okay. This is the same direction as I2. So this is positive 8. Then plus 3 I2 equals to 0. So you will get this equation for mesh 2. Okay, you simplify, you will get negative 12 I1 plus 24 I2 equals to negative 8. And use your calculator to solve for these two simultaneous equations. You will get I1 equals to 666.7 milliamp and I2 is equals to 0 amp. appear. Okay. Okay, so next we continue with example 3. Okay, so now for example 3, we have 3 loops. Okay, 1, 2, 3, 3 loops. So since we have 3 loops, then we have 3 mesh current, I1, I2. However, the question asks you to calculate for the I0. So the I0 is over here. Okay, I0 is over here. So in order to find I0, later we need to use KCL. Okay, but before we can find I0, then we need to find I1 and also I2 first. So same steps. So we have 3 mesh current, I1, I2 and also I3. Next, do KVL for each loop. So for loop 1, this is loop 1. So this is negative 24 plus you have a resistor in between 2 loops. Okay, so this will become 10 multiplied with I1 and minus I2 because the current over here is I2 plus this one is located in between loop 1 and loop 3. So this one, the voltage should become 12 multiplied with I1 minus I3 equals to 0. So if you simplify this, you will get 22 I1 minus 10 I2 minus 12 I3 is equals to 24. So this is the first equation, equation 1. Next, let's look at the second loop. Okay, this is the second loop. Okay, so the first resistor is this 10 ohm. So 10 ohm, the voltage across 10 ohm is 10 multiplied with I2 minus I1 plus this one. This is 24 I2 plus this is 4 I2 minus I3 equals to 0. Okay, this equation. Simplify the equation, you will get negative 10 I1 plus 38 I2 minus 4 I3 is equals to 0. So this is the second loop. Now the KVL equation for loop 3. So loop 3 over here. So if you look at here, for the loop 3, we have a dependent voltage source. Okay, this is a dependent voltage source. So the KVL for the loop 3 is 12 multiplied with I3 minus I1 plus 4 multiplied with I3 minus I2 plus this is 4I0. Okay, plus 4I0 because the voltage here is equals to 4I0 equals to 0. Okay, so simplify this equation, you will get this equation. Okay, but before that, since you have I0 over here, if you use KCL over here, we know that I1 is equals to I2 plus I0. So I0 is actually I1 minus I2. So you change this I0, I1 equals to I1 minus I2 in this equation. Okay, so instead of 4I0, it will become 4 multiplied with I1 minus I2. Then only you can get the final simplified equation, which is negative 8I1 minus 8I2 plus 16I3 is equals to 0. Okay, then only you can solve for the simultaneous equation. If you do not change this, you cannot solve for the simultaneous equation using the calculator. Okay, so use your calculator to solve for these three simultaneous equations with three unknowns, and you can directly get I1, I2, and also I3. Okay, so I1 is 2.25 ampere, I2 is 0.75 ampere, and I3 is 1.5 ampere. Okay, however, the question asks you to find I0. Okay, so you already know that I0 is equals to I1 minus I2. So I1 is 2.25 minus 0.75. You will get equals to 1.5 ampere. Okay, any question? So if no question, we will proceed with the next example. This is example 4. Okay, so no question. Okay, so we'll proceed with example 4. Okay, so example 4, you still have three mesh. Okay, so I label this as I1, I2, and also I3. Okay, directly find the KVL equation for each loop. So the first loop over here, this is negative 20 plus 4 multiplied with I1 minus I2 plus 2 multiplied with I1, this is I3, plus 2 multiplied with I1 minus I2 is equals to 0. Okay. Simplify this equation, you will get 6I1 minus 2I2 minus 4I3 is equals to 20. So this is the first equation. The second equation, based on the second loop, okay, so the second equation for the second loop, so we have 2 multiplied with I2 minus I1 plus 8 multiplied with I2 minus I3, and we have a dependent voltage source over here. You look at this one is negative positive, so the current direction, so this is opposite of current I2, so it becomes negative 10 I0. So this is equals to 0. Okay, so you have this equation. Okay, however, this equation you have the I0. Okay, you need to change this I0 in order to solve for the simultaneous equation. Okay, so from this circuit, you can actually see that I0, the I0 is over here. So I0 is actually current I3. This is current I3. Okay, so that's why actually the current I3. That's why I put here I0 is equals to I3. Okay, so you change I0 to I3, then only you can get this equation, negative 2I1 plus 10I2 minus 18I3 equals to 0. Okay. And then next, mesh 3. Mesh 3 is this one. This is 4 multiplied with I3 minus I1 plus 6I3 plus 8 multiply with I3 minus I2 equals to 0. Simplify the equation, you will get negative 4I1 minus 8I2 plus 18I3 equals to 0. Use your calculator to solve for the three simultaneous equation. You can directly get I1 equals to negative 3.214 ampere, I2 equals to 9.643 ampere, and also I3 equals to negative 5 ampere. Okay, and however, the question asks you to find I0. Okay, but before this, we already know that I0 is equals to I3. So basically, I0 is equals to I3 is equals to negative 5 ampere. So the final answer is I0 is equals to negative 5 ampere. Okay. Next example is example 5. So basically the step is the same. Okay, you just follow the step and you can calculate for the current. Okay, so usually we use the mesh analysis to calculate for the current. If you want to calculate for the voltage, usually we'll use the nodal analysis that you have learned last week. Okay. Next example 5. Okay, so over here we only have two loops, I1 and also I2. The question asks you to find current through 6 ohm. So 6 ohm is over here. So basically the question asks you to find the current over here, the current that flows through 6 ohm. So I label this as, because this is I1, this is I2, so I label this as I3. Okay, so this is basically I1, this is I2. So this is I3. So now let's do KVL for each of the loop. So for mesh 1, we have negative 10 plus 4I1 plus 6 multiplied with I1 minus I2 equals to 0. And you will get 10I1 minus negative 6I2. For this one, actually, you don't need to do the KVL because you already know that the current here is equals to 5 ampere because this is a current source. Okay. In the previous example, we use voltage source. Okay. But this one is the current source. So basically you can directly know that I2 is equals to 5 ampere. You don't need to do the KVL. Okay. But if you look at the direction, this is clockwise. This is the direction is upwards. It is counterclockwise. So because it's different direction to the I2, okay, so basically I2 is equals to negative 5 ampere. Okay, get it? Okay, so I name this as equation 1 and this is equation 2. So I put equation 2 into equation 1, meaning I change I2 equals to negative 5 into this equation. Then you can calculate for I1, which is equals to negative 2 ampere. Okay. And to calculate for I3, you know that I1 is equals to I2 plus I3. So I3 equals to I1 minus I2. You will get equals to 3 ampere. Okay, so any question? Any question?
No, madam.
Yeah. No, okay. Okay, so next is example 3.2 on page 86 in the Sadiku textbook. So this one is Okay, so this one is a little bit different because the question actually asked you to calculate for the V2. Okay. The question is use mesh analysis to find V2. V2 is over here. Okay, the voltage, the nodal voltage, V2 over here. Okay, you have, if you can see, this is V2. So V2 is actually from this point to ground. The question asks you to find the V2 using mesh analysis. Like I explained to you before, if your question asks you to calculate for the voltage, it's easier for you to use nodal analysis. But if the question asks you to calculate for the current, then it's easier for you to use mesh analysis. That's what that you can choose whether to use nodal or mesh if the questions doesn't stated which analysis you need to use. Okay, but if the question asks you to calculate for the voltage using mesh, then you need to use mesh. Okay, but you can see that over here the calculation is a little bit complicated compared if you use nodal analysis to find for the voltage. So later maybe you can try this one using the nodal analysis that you have learned last week to get V2. Okay. But still we can use mesh. So over here we have three loops, 1, 2 and 3. So the for the loop 1 here, I1 is equals to 3. Okay, because we have a current source over here. So we can directly know that I1 is equals to 3. Okay, no need to do KVL. For mesh 2, this is mesh 2. Mesh 2 is 4 multiplied with I2 minus I1 plus 8 multiplied with I2. So this one is, this is 248. 248. Okay, sorry, this is mesh 2, this is mesh 3. Yes, this is mesh 2, this is mesh 3. Okay, so this is mesh 2. So the mesh 2 is 4. This is mesh 2. Wait, 2 I3 minus I1 plus 4. So is this equation correct? This is mesh 2. Okay, so this is mesh 2. Okay, so this is 4 I2 minus I1 plus 8 I3 minus I.
I2 minus I3, right, Doctor?
Yeah, I2 minus I3, I think this one. Okay, so please correct this one, I2 minus I3. So you will get this equation. For mesh 3, this is 2 multiplied with I3 minus I1 plus 4 I3 plus 8 I3 minus I2. So you will get this equation. Okay. So you know that I2 is equals to 2Ix. This is I2. Okay. So I2 is equals to 2Ix. Okay. So you change I2. So you will get this equation. Negative 2I1 minus 8I2 plus 14I3. So this I2, I change it to become 2Ix, this one. So you will get this equation. Okay, negative 2i1 minus 16ix plus 14i3 equals to 0. Okay, so since you have ix over here, do a nodal analysis here. So you know that ix is equals to i1 minus i3. Okay, this is i1, this is i3. So ix is equals to i1 minus i3. So 16 multiplied with i1 minus i3. So you solve for this equation and you will get I3 equals to 1.8. Okay, so I3 equals to 1.8. And lastly, the question, remember the question asked you to find the voltage at node 2 over here. Okay, so the voltage at node 2 is basically from this point to the ground over here. So this, so I name this current as I4. Okay, take note that I name this current as I4. So that's why we have V2, this is Ohm's law, V2 equals to 4I4. Okay, V2 equals to 4I4 because it is the current across the 4 ohm. Okay, and I1 is equals to I4 plus I2. This is the KCL at this node 2. So this is I1, this is I2. So I1 is equals to I4 plus I2. So I4 is equals to I1 minus I2. Okay. So I1 is 3. I2 is 2Ix. Okay. And Ix is I1 minus I3. Put in the values, you will get I4 equals to 0.6. So after you get I4, then only you can use Ohm's law to calculate for the V at node 2. So V at node 2 is 4 multiplied with I4. Okay, so I4 is 0.6 and lastly the voltage is 2.4 volts. Okay. So later I want you to solve this circuit but try to use the nodal analysis. Okay. So if you compare this one and this one use mesh analysis to calculate for the current. This one is mesh analysis is used to calculate for the voltage. Okay, so the calculation for this one is just a little bit longer lah compared to this one. Okay. So this example we have covered just now. This is example 1, example 2, example 3, example 4, and also example 5, and example 3.2. Okay, so all of this we have covered just now. So you can download the PDF file in your ulearn. Okay. So this one, I think I don't want to discuss because this is your tutorial. Okay. Remember your tutorial, you have another 3 questions for you to solve. Okay, so if you look at in your ulearn, okay, so now is week 6. So this is week 6. Okay, so you need to do your tutorial 2 for question 32 and also question 33. Okay, over here I already uploaded the answer for tutorial 2, answer scheme for tutorial 2. So later you can check your answer and your calculation as a preparation for your midterm test. Okay. So the tutorial 2 for questions 33 is this one. Okay, I don't think I want to discuss. Basically, the flow is the same as the previous examples. Okay, just find the KVL equation and then solve for the simultaneous equation and so on. Okay, so and also over here you actually already have the calculation. So this is tutorial 2 number 31, and lastly you can also try this one. This is an example from the study cook textbook, if I'm not mistaken. Okay, so you try these 3 example by yourself. Okay, so make sure that you get the correct answer. So over here, you already have the answer, but the KVL equation over here is directly given. Okay, so before you can get this equation, then you need to follow the steps. Okay, one by one. Okay, so as a summary, for the circuit analysis, we have nodal analysis and we also have mesh analysis. So which one to use? Which one is better, nodal or mesh? Okay, so basically to select the method that result in the smaller number of equations. Okay, so if you should choose nodal analysis for a circuit with fewer nodes than meshes. Okay, I hope that you can understand this sentence. If the circuit has a fewer nodes compared to mesh, then it is better for you to use nodal analysis. However, if the circuit have a fewer mesh compared to nodes, then it's better for you to use mesh analysis. Okay, and networks that contain many series connected elements are more suitable for mesh analysis, and networks with parallel connected elements are more suitable for the nodal analysis. Okay, so basically for a circuit, it depends on you whether you want to use nodal or you want to use mesh. Okay, if you think mesh is easier, then you can use mesh. If the question does not state which method to use. Okay. But in your test, it is stated which method to use. Okay, so even though maybe you like your mesh analysis, but the question asks you to do nodal, then you need to do nodal analysis. Okay, so if node voltage are required, it may be expedient to apply nodal analysis. If branch mesh current are required, it may be better to use mesh analysis. This one I already explained to you before. So any question for the mesh analysis? Any question for chapter 2? Or your test, midterm test? For your midterm test, I don't have the date yet. The coordinator has not finalized the date yet, but she said maybe next week or the following week. So any question?
Madam.
Ya.
Apa ni? Midterm break ada ke?
Midterm break?
Bukan break.
Kan
Macam tak
ni kan soalan ni. Midterm break ada sepatutnya. Saya tak sure. Nanti saya confirmkan.
Sebab saya nampak macam tak ada.
Tak ada eh? Nanti saya confirmkan. Nanti saya letak dalam grup. Ada ke tak?
Doktor,
midterm
chapter 1, chapter 2 lah.
Midterm chapter 2, chapter 3.
Oh.
Chapter 2, chapter 1 not included in midterm eh. Chapter 1 mostly theory, right? So in your midterm test will cover chapter 2 and also chapter 3. Chapter 3 is electronics part. Okay, so chapter 3 we will cover on Thursday. Okay, but the marks for the midterm test is basically mostly from chapter 2. Okay, only a small portion from chapter 3. Okay, so chapter 3 is more to the theoretical part. Calculation part, chapter 2. Okay, any question? Okay, so you need to focus on chapter 2 lah, the calculation. Okay, so for class on Thursday, we will cover, supposedly actually if you refer to your teaching plan, the chapter 3, we actually should cover on week 7, which is next week. However, because I'm not sure whether your test is week 7 or week 8, and because in your midterm test there's a small portion of chapter 3, then that is why I wanted to cover chapter 3 this week. Okay, but if you look at in your teaching plan, supposedly we should cover chapter 3 next week. Okay, so on Thursday we'll start. So now we have finished the electrical part. Start from this Thursday until week 14, we will cover on the electronics part. Okay, and the notes are already uploaded in the ULearn for week 7. Okay, I already uploaded in the ULearn. This is chapter 3 and this is the tutorial 3. Okay, for other than that, if you want to so your tutorial 1 answer scheme is here, week 1. Okay, so any more question? So your midterm test we will use ULearn. Same like quiz 1, we will use ULearn for your midterm test. Okay, so any more questions before we end? So if you have any problems regarding your tutorial 2, you can just directly DM me. Okay.
I have problem.
Yeah.
I have problem for tutorial 2, question number 25.
Question number 25.
Yep.
Okay. So question number 25 said that ask you what value of R in the following circuit would cause the current source to deliver 800 milliwatt to the resistor. What value of R in the following circuit would cause the current source to deliver 800 milliwatt to the resistor? Okay, so basically this one is a reverse analysis. Okay, usually you are given a circuit, you are required to find the power, but now you are given the power, the question asks you to find the resistor. Okay, so it is reverse analysis. So basically what you need to do is that you know that the P is 800 milliwatt. Okay, so P is equals to I squared R. The R over here is the R total or the R equivalent. Okay, this is the R total or the R equivalent. So R equivalent or the R total R equivalent for this resistor is 888.89. This is the R equivalent. Okay. For this circuit, remember, this is not a series circuit, this is not a parallel circuit, then you need to use the Y delta transformation. Okay. So from this question, okay, over here, we use delta to star transformation. Okay, so this is delta connection. This is delta connection. We change it to a star connection. Okay, so this we name it as resistor A. This is resistor B and resistor C. Okay. Okay. So using the equation in your, I think, part 5. So resistor A is R multiply with R divide by R plus R plus R. Okay. If you remember the formula for the delta star transformation. Okay. So this, because this resistor is labeled as R, so that's why we use R multiply with R divide by R plus R plus R. Okay, because the R here is the value is the same. Okay, so A is equals to R divided by 3. If you simplify this, you will get R over 3. So because so for RB and also RC, basically the equation is the same. R over 3. RC is also R over 3. Okay. Then only you can calculate for this one. This circuit, okay, this part we already changed to star, so that's why we have this circuit instead. Okay, and you solve for this one. Okay, so this is R series A is parallel with this. If you look at here, this R series with A, this is R series B. Okay, so R series A is parallel with R series B. Okay, and you will get this equation. Okay, this is normal parallel calculation, series parallel calculation. Okay, it's just that you use the value R. So you will get this equation, and lastly you will get this is equals to 2R.
Doctor,
Okay, so 2R, this is 2R. So R total is 2R because 2R now is in series with C. So lastly, you should get this R equivalent is 888.89. So you will get R equals to 380.95.
Doctor.
Yeah.
I just don't understand why when R series A parallel to R series B get 2R. When I try to calculate, I get 2 over 3R.
This one,
Yes,
you don't get 2R, is it?
yes. I got 2 over 3R.
Can I check first and then I share it in the Telegram?
Okay, can.
Okay, so I need to calculate this one again. Then I will share it in the Telegram. Whether R series A is parallel with R series B, we'll get 2R.
Okay.
Okay.
Thanks, Doctor.
Okay, so any more question? So if no questions, then we will continue our class on Thursday at 2 p.m. Okay, so thank you very much.
Doktor,
Yeah,
biasanya midterm berapa jam?
midterm 1.5 jam.
Lepas tu kita nak PDF kan jawapan semua. Berapa minit dia bagi?
That one nanti saya confirmkan dengan penelaras.
Okey, terima kasih doktor.
Okay. So biasanya kita memang akan bagi masa lebih lah sebab kalau face to face memang 1 jam setengah. So because dia sebab ini online, so biasanya kita memang akan bagi lebih lah macam final exam awak tahun lepas, SEM lepas.
Okey.
Okay, so
Oh, fine.
actually berapa minit tu saya tak sure lagi.
Okey, terima kasih.
Okay. Okay, so thank you.
Thank you, Doktor. Assalamualaikum.
Salam.